All right, welcome back for the next lesson here, lesson 23, base angles of an isosceles triangle. So we're going to start with a little opening exercise. All right, so take a look at the first one. What other information do you need in order to show that these two triangles are congruent? And we have to use the side angle side congruence theorem, okay? So take a look at it. All right, make sure you mark down what you have. What else can you show? And then what else do you need? All right, so for this one, we already knew that these two sides were equal. And keep in mind, we always want to identify the two triangles. Here we're talking about triangle ABC, so that's this triangle right here, okay? And the other triangle is going to be, we'll do green here, is going to be this triangle, which is, right, DCB, so this triangle in green. Okay, so we do already know that these two sides are equal, right? So what else can we show? We can show that BC is congruent to BC. Remember, that's reflexive. Okay, and then remember, if you're having a hard time seeing it, just redraw your triangle. So if this is DCB over here, we have this side and this side. So what angle do we need to get side, angle, side? We need that included angle. Okay, so that would be this guy right here in the corner. We don't necessarily know that it's a right angle, just that it's got to be congruent to this one. Okay, so we also need angle DCB congruent to angle ABC. And there's side, angle, side. So strategies, make sure you highlight, label, and then redraw your figure if you're having a hard time identifying the congruence theorem. All right, try the next one. Make sure you mark down AB, okay? That's this side right here, is congruent to RS, okay? And we know that AB is parallel to RS. Okay, let's see what you got. All right, so hopefully you identified your two triangles. We labeled what we have. So we need this angle down here in the corner. So that's angle ABC. We got to use the three letters because there's two angle B's, right? The one on the left and the one on the right over here. Okay, congruent to angle RST. And then we also need this segment on the bottom, right, CB, to be congruent to this segment on the bottom, which is TS. Now there's another option because we had these two sides congruent, right? You could try to get these two sides equal and then these two sides, but with the parallel lines, these are the corresponding angles. So these are the ones you'd be able to get congruent. So I would say this is going to be very difficult to show without drawing an auxiliary line here, okay? And then getting that. But I would have taken angle A congruent to angle R and AC congruent to RT. If you wrote that down, that would be acceptable. But this would be the easier way. All right. So we're going to be spending some more time talking about specifically about isosceles triangles today. All right. So keep in mind a couple things. All right. We are going to talk about the fact that we can use the transformation to do this, and we can also use the side angle side criteria. So if you look at isosceles triangle ABC, we know two things, right? It has at least two congruent sides and has two congruent what are called base angles. Okay, remember the angles are always across from the sides. So once we know where the sides are, the angles are across, and once we know where the angles are, the sides are across. Okay, so two ways that we're going to show, well, the one way we're going to really show that these two sides are equal and the two angles is the fact that we're going to create an angle bisector or a perpendicular bisector of segment BC. Okay, so if we start with an isosceles triangle and AB congruent to AC, we want to prove that these two angles are equal. So we're just going to construct the bisector of angle A, and this angle is also going to become the perpendicular bisector of DC. So if we do a reflection over that line, this point B would map onto C, D would map onto itself, and this angle, right, BAD and CAD would overlap, would map onto each other. And so we'd know that this triangle is congruent because all the sides and angles are mapping onto each other themselves. Your other option, if you remember, right now we could also state that this side is congruent to itself with reflexive, and then we have side, angle, side, or side, 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 in order to show that these are congruent. So those are our options there. I'm not going to spend a lot of time doing the proof. We're just going to basically use it in our proofs, okay? So what I want to do is on page 126 here, we're going to write down our method for using isosceles triangles in our proofs, okay? So to use the isosceles triangle in a proof, okay? Step one, we actually have to prove it's an isosceles triangle. I'm going to say triangle A, B, C is isosceles. Okay, that's going to be the statement. And then the reason, so let me just, for sake of doing this, and move this down just a little bit here. Okay, so these are going to be the statements. All right. Let's switch to red real quick here. So statements. And these are going to be the reasons over here. All right. Now, when you say that it's an isosceles triangle, you're either going to know that there's two sides equal or there's two angles equal. Okay. So you're just going to say, right, that isosceles triangle has two sides, okay, or angles. You pick which one we have based on the picture or the given congruent. Then we're going to use this now to prove, okay, that either the two sides are congruent, so AB is congruent to AC, or we could prove that angle B is congruent to angle C. So this is whatever you need. If you know the angles are equal, okay, then we're going to prove the sides are congruent. And if we know that the sides are congruent, then we would want to use that to get the angles congruent. And all you're going to say is the legs or the base angles, okay, of an isosceles triangle are congruent. So once again, if you want to use the sides, we're going to put the legs. If you want to use the angles, you're going to put the base angles. That's it. Okay, so that's how we're going to use it in a proof. So let's go ahead and try that on the next page here. Okay, take a look at exercise 1. So same thing, let's start with the T-chart. Now, unlike yesterday, we're actually going to write out the statements and reasons. So statements, okay, reasons. First one's the given, so JK congruent to JL, and then JR bisects KL, and this is given. Okay, now remember, things we're going to start with. Number 1, label your figure. So look at your given. Are there anything that we know automatically from the given? Yes, we know that these two sides are congruent, so label it. JK congruent to JL. Got it. Okay, step 2. Step 2, okay, in our proof, we want to look for keywords in the given. Okay, see the word bisects. That's going to create a new statement for us. Okay, so what does it mean to bisect? We're cutting in half. What are we cutting in half? KL. So if I cut KL in half, I get these two segments equal. So I can say that KR is congruent to RL, and I'm going to use that word in my reason, okay? So I'm going to say, right, and it's always the same thing here. Bisector cuts, what are we cutting, right? These are segments into two equal parts. Okay, now let's stop for a minute. We're going to change this proof statement, okay? Instead of doing perpendicular, we're just going to do triangle. JKR is congruent to triangle JLR. We don't have the tools yet to do this. We're going to get there, but we're not there yet, okay? So let's go to step 3. Now, third thing we're going to do, look at your picture, okay? Do you see anything here? We're looking for anything that's overlapping, okay? We're looking for vertical angles, all right? We're looking for the Z's, knees, right? For the parallel lines. Looking for all sorts of stuff. We got to have parallel lines first, though, okay? So that's what we're looking for when we look at the picture. So if I look here, right, we have our 2 triangles, and we have that line down the middle again. So we got that reflexive property. So now I can say that JR is congruent to JR, okay? And that's the reflexive property. The property, of course, that's equal, right? And now do I have enough to say they're congruent? So look at your triangles, right? Do we have either SAS? Do we have SSS? Do we have ASA? Do we have AAS? Or do we have HL? If and only if we have right triangles first, okay? So what do we got? We have side, side, side. All 3 sides are equal. So we do have enough. So step 4, we're going to say triangle JKR is congruent to triangle JLR. And notice that we've put the corresponding letters in order. And then we're going to write SSS for the first triangle is congruent to the side, side, side in the second triangle. Awesome. Okay. Slide down to number 2. Go ahead and do your T-chart and fill in your statements and reasons. And then pause it. Okay. And then fill that in and then press play. Okay. So once again, we're going to change the given here. So don't cross it out too much. We're actually come back to this. We're going to do triangle AXB is congruent to triangle AXC. Okay, let's see if you can try this one on your own. All right, so it should take you 3 steps to make this happen. All right, so pause it, see if you can fill it on your own, and then we're coming right back. No, seriously, pause it, try it on your own. All right, so hopefully you got the AX congruent to AX in the middle here with reflexive property, and then we can say the triangles are congruent. And remember, if we look at our picture, we have the 3 sides congruent again. So side, 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 congruent to side, side, side. Okay, wanted to come back up to this question because there actually is another way to do this one. And I wanted to touch on it because we wanted to, remember, we're talking about isosceles triangles. We could have also gotten these 2 base angles congruent and used side angle side. So to do that, okay, we're going to call this step 3A because there's another step. We would have said that triangle JKR is isosceles. Okay, and then for 3B, I'm going to take an extra step. We could have said that angle K is congruent to angle L. So that would have been how we would have gotten those 2 angles to be equal here. So remember, this one is going to be the 2 sides of an isosceles triangle are congruent, and this one would have been base angles of an isosceles triangle are congruent. Now, just like we did before, right, you could have said isosceles triangles have 2 congruent sides. So if you wanted to write that, we'd write that instead, totally fine as well. Okay, so that would have been our another option here. And the reason I'm going over that is because we need it for this question. Okay, so let's do it. We want to show, so once again, JX is congruent to JY. Okay, KX is congruent to LY. And let's see if we can get these 2 things to happen. So what we're going to do actually, once again, we're not going to do this. I want to show that triangle JKX is congruent to triangle JLY. So let's see if we can get this to happen. Okay, and then if you're having a hard time, remember we can identify and trace over our triangles. Okay, so we're going to go back and do this in red real quick. Maybe. Sorry, sometimes I have to do some control or Alt tab there to get it to recognize that I'm in this again. Here we go. Okay, those two triangles congruent. So let's start it off. Do this one together because we're this is a little different, a little more difficult question here. So number one, JX is congruent to JY, and KX is congruent to LY. There's no keywords, so we're going to have to rely on what this shows us and then our diagram itself. This is a given. Okay, so let's mark down what we know. JX is congruent to JY, and then KX, we're going to put 2 slashes through here, is congruent to LY. So what else can we show, right? So either I'm going to need to get that these two sides over here are equal, to get side, 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 or that these two angles where 3 and 4 are going to be equal. Because if I get any of the other angles, I'm going to have the donkey theorem, right? Angle, side, side, okay? So what we really want to focus on for this question is this inside triangle. This is going to be the helpful one, okay? What type of triangle is this, all right? So let's see if we can do our steps. So number 2, right, if it has two sides congruent, we know that triangle JXY is isosceles. And then how are we going to prove it, right? Isosceles triangles have two congruent sides, or you can say a triangle with two congruent sides is isosceles. Any way you want to put it, that's fine. Okay, as long as it makes mathematical sense, you're good. Now that we know that it's isosceles and these two sides are congruent, then we know that these two base angles are going to be congruent. So we can say angle 1 is going to be congruent to angle 2. Okay, and this is going to be the base angles of an isosceles. Oh, spell that wrong. Isosceles triangle are congruent. Okay, now our job is to get 3, right, congruent to 4. So how do we start with these two equal and end up with these two? Think about it for a second. See it? Hopefully. These pairs of angles are the key, right? They make a linear pair, so they're both going to add to 180. And once they're equal to 180, we can set them equal to each other and take away the 1 and the 2. So let's do it. So we're going to do angle 1 plus angle 3 equals 180. And then angle 2 plus angle 4 equals 180. Now, the reason why we number these is because you can see sometimes that they don't line up perfectly, like 4 is down here now. So it doesn't matter if these are like take up more room than this side. Okay, and then what's the reason? Remember, we can write, there's a few reasons we can put down. We'll put down the old linear pairs of angles add to 180 degrees. Now, could have said, right, supplementary angles add to 180 or angles on a straight line. So a few options for you. If you wrote something different, that's okay. Okay, remember, we want to end up with angle 3 congruent to angle 4 here. So once we have the equations equal to 180, we need to Good. Set them equal to each other. Okay. All right. So when we set them equal to each other, remember that's either substitution or we can put transitive. All right. And then the last one, how do we get these two to cancel out? We have to use the subtraction property of equality. All right, so let's do it. We finish it off now. Do we have enough to say that these two triangles are equal? Okay. And now that we mark this down, right, we'll put 2 arcs here. Do we have enough to say that those are equal? So let's look. Remember, we can redraw the triangle. Oh, that's terrible. Okay, so we have a side, an angle, and then the side down here. So we have side, angle, side. Okay, so triangle JKX is congruent to triangle JLY. All right, and then we're just going to do side, angle, side, congruent to side, angle, side. Okay, that's our lesson for today.